we'll discuss about the data engineering concept. I hope my screen is visible to everyone. If you are facing any audio issues or if you are not able to see my screen, please you can unmute yourself and you can speak. So, so this course, as I told, it will be mainly focused on the data engineering concept and what are the relevant services we have in Google Cloud, like BigQuery, data flow, Cloud Composer. We'll discuss about all those services. Okay, and also this course will also help you to clear the certification exam of Google Cloud. You can go for, after the completion of the course, you can go for the data engineering certification exam as well. Yeah, so let's start. Let's first of all understand what is data engineering. May I know how many of you are already working in as a data engineer in your current company? Maybe you might be using some other services, not Google Cloud, but you might be working as a already data engineer. Can you guys speak?
Yeah, I'm working. This is Rikar.
Okay, so you are working in you are using Google Cloud or any other cloud services? How is it?
No, as of now, now it is migrating actually. We are using Hadoop and we are migrating into the GCP.
Okay, fine. Anybody else who is working as a data engineer?
Sure. I'm working on data engineering. We are migrating data sets to GCP.
Sorry?
We are migrating data state utility tool to GCP. So we are using some GCP services.
Okay.
Yes.
Okay. Anybody else? Okay, fine. Okay, so let's start. So guys, in case of data engineering, so what we usually do, so there will be in general, in case of in general data pipeline, there will be source systems, okay, where we will ingest our data to some platform, be it Google Cloud or be it Azure or be it AWS. We'll ingest the data and then we'll do some data processing, and then finally we'll load the data to some data warehouse, or the data will integrate with the BI platform, and will produce our report on the BI. So that's how the usual data engineering pipeline looks like. Okay, so in general, data engineering, it consists of development, implementation, and maintenance of your system, where you have to process the raw data, and then you'll have to produce you'll have to transform your data. You'll have to so those transform data will be used by your downstream use cases. So in case of downstream use cases, in some project you'll see that might be a blockchain team who will be using your transform data, or that could be a machine learning or analytics team, or that could be a reporting team who will be using your transform data. Okay, so but right now the data engineering scenario has changed. Earlier we used to just develop and implement our pipeline. So right now, along with the development of the pipeline, so in the slide which you can see, so let's say there is a generation source from where we are generating the data, then we are ingesting the data, any storage system we are using, and then we are ingesting the data, then we are doing some transformation, and then we are loading the data to our serving layer, or you can say the final layer, or the data warehousing layer, and that is being used by the analytics team or machine learning team or any ETL team. Okay, so that's the usual data engineering pipeline or data engineering life cycle looks like. But apart from that, also nowadays we'll have to consider the security of the data when you are transforming your data. When your data is in transit or in rest, you have to maintain the data security. You have to also maintain the data governance. Okay, you have to do the metadata management, and also if your how scalable your pipeline is. So let's say tomorrow your data volume grows. Okay, so how scalable your pipeline means that will come under the data ops part. So whether how much changes you need to do in your pipeline and how easily you can deliver your pipeline in a smooth manner. So that depends on your how you have designed your pipeline. Okay, so that also you need to consider when you are creating a pipeline, and also how you are going to orchestrate your complete pipeline. So all these things will come under the data engineering life cycle. Okay. So we'll have a generation source, we'll have storage ingestion, and then also we'll have to consider the security part, the data management part, and the data architecture part. Okay, so that is all about the data engineering in general. And if you'll see how the data system has evolved throughout the years. So in earlier days, we had a DBMS system where like we used to store the data in some DBMS system like Oracle DB or some other DBMS system. After that, we started using the warehouse concept. Okay, because as the data volume grows, so we tried to process our data parallelly. So so that at that time, like around 80s or 90s, we started using the warehousing concept, data warehousing concept, and different kinds of modeling or data modeling we started using. Okay, and after in 20s, so what happened, like so earlier we used to focus only on the batch data because the data volume was comparatively less. But in 20s, when the data volume when the data volume grew, so at that time what happened, like the also the web data and the unstructured data came into the market. Okay, so we had to also process all those data as well. So just not just only the batch processing, also we had to focus on the streaming processing of the data as well. So that time, like the NoSQL concept or NoSQL databases came into the market or came in the field, and we started using various NoSQL databases like Cassandra, HBase, and all. In 2010s, so what happened, like again our data volume, so the data volume and the data variety of the data, so everything is changing rapidly. Okay, so around 2010s, we started moving towards the cloud platform because of various reasons. Because in cloud platform, your data storage and everything, all the cost will be less compared to your on-premises. Also, for the maintenance of the platform and to do the configuration management, to do the infrastructure management, to reduce the upfront fees what will pay in case of on-premises system, everything will get reduced if you will move to the cloud platform. So because of all those advantages, we started moving towards the cloud platform. And so if you'll see in your data pipeline, there will be many layers of the data. So we started creating data lake layer, which will be your staging layer or the raw layer you call in your project. After that, you'll have to process your data. Then you'll have to store your process data in the data warehousing layer, which you can call your final layer or the serving layer. Okay. But right now, you might be, if you are in the data domain, you might be hearing about the new concept, which is called the lake house, the data lake house, which we started using this concept around 2020s, very recently. So mainly, if you see the data bricks is working heavily on this data lake house concept, using the delta lake. If you have some idea about the delta lake, then you can then you'll be able to know, like in case of delta lake, you can manage both the historical as well as the current data. Also, you can create schema and everything in case of using delta lake. So using all those features of the delta lake, Databricks is working on the data lakehouse concept, and right now industry is moving towards that data lakehouse. Okay, So that is how the data system has evolved throughout these years. Okay. So right now you might be hearing about this data mesh, data fabric, data lakehouse. So all these are very new concept in the data field. Okay. But in general, if you see the data engineering pipeline, we'll have some ingestion, we'll have a source system, but we'll have some ingestion system from where we'll ingest the data. Once we'll ingest, let's, for example, some of you are already working on the migration project where you are migrating the data from Hadoop system, from Teradata system, or from any kind of SQL system into Google Cloud. So in that case, what will you'll be doing, you'll have to create an ingestion pipeline, okay, so that you can ingest your data from your Hadoop or from Teradata or from SQL, and you can store the data in some storage system. So you can use, let's say, if you are using any kind of unstructured data, for example, you can go for the cloud storage, you can store, or you can store in the cloud SQL. So these are the services which are available in GCP. So similarly, if you are using any kind of, let's say, Cassandra or HBase, so that's, for that we have different kind of NoSQL services like Bigtable and Cloud Data Store, which are available in the Google Cloud. So you can also store your data there. Okay. Once you'll store your data, so there is some reason why we are storing the data in some storage services. So once you store your data, then what you can do, you can process and analyze your data. Okay. So for the processing and analysis of the data in GCP, we have many services, like you can process and analyze your data just by using BigQuery. So also you can do it using Dataproc, using Dataflow, using Data Fusion as well. Okay. So these are the services which are available in Google Cloud, where you can do you can process and analyze your data. Yeah, there are many services, but those services have different features. When to use which kind of services, you'll be able to know once we'll started discussing more about those services. Okay. And once you store your data, for example, in the data warehouse, you have stored, let's say, BigQuery, you have to you'll want to visualize your data, you'll want to produce some report on top of your data, or let's say your analytics or a machine learning team might be might want to use those data which you have stored on your data warehouse. Okay. So they can integrate with the BigQuery, or also if you want to create if you want to store right now, if you'll see many pipeline in many data engineering pipeline, they are storing the data in direct Snowflake. Okay. So you can also do that. You can integrate Snowflake, because Snowflake is a different application, it's a third-party application. You can integrate with that with any of the cloud platform, AWS, GCP, Azure, with any of the platform, and you can store your data in Snowflake as well. So so that is how in general a data pipeline looks. So you have the ingestion, storage, and the process and visualize system. Okay. So let's see what are the services we have in GCP for data ingestion. Okay. So we have different kinds of data and we have different kinds of processing system. Okay. So for example, we have so let's say we have for the batch processing for to store the structured data or unstructured data. But in case of batch processing, we normally prefer cloud storage, or that is storage transfer services. Okay, using the storage transfer services, you can ingest the data from your on-premises system and you can store the data in cloud storage. Also, you can schedule that as well. We have BigQuery transfer services as well. So where you can ingest your data directly from the on-premises system or from any other, not only from on-premises system. If you have data in any other cloud platform like Azure Blob Storage or AWS S3, from there also you can ingest your data and you can store your data either in cloud storage or in BigQuery tables as well. If you have a high volume of the data, if your data volume is very high, in that case, what Google suggests you to go for the transport appliances. So there are some hardware devices which are there, and if you opt for that, let's say you have a huge volume of the data, which petabyte of the data you want to transfer. from on-premises system or from a different system to Google Cloud. So in that case, Google will suggest you to go for the transfer appliances. So it will ask you to provide your address to where they can shift your transfer appliances. Okay, so you'll receive some kind of hardware devices. Using that hardware devices, you can also transfer your data to Google Cloud. Okay, so this was about the batch data and the batch processing of the data. Coming to the streaming processing. So in streaming processing, if you have used Hadoop system, we have Kafka or Spark streaming. We use for streaming processing of the streaming data. Similarly, we have PubSub, okay, which is known as publisher and subscriber. So that we use in case of Google Cloud to deal with the streaming data. Okay, so it's the concept of PubSub and Kafka are almost same. You can create a topics in PubSub, you can create publisher, you can create subscriber. So publisher can publish their messages to the topic, and subscriber can either push or you can pull the messages to the subscriber. Okay, you can create multiple publisher, you can create multiple publisher can publish their message to one topic, multiple subscriber can subscribe their message from the one topic. So all those things you can do in PubSub. Okay, you can transfer your data. If you are you can ingest the streaming data to PubSub, and you can store it in Google Cloud Storage. Also, you can store it in any other data warehousing system like BigQuery or Bigtable. You can do that. Okay, and then coming to the application data, let's say you have some front-end application, okay, where you are generating some kind of user, let's say user activities or user behavior, okay, where user is clicking and all those things you are generating. So from the front-end application, if you are generating some kind of data, so you can also store that in case of logging data, you can store, or else if it is structured data, you can store it in Cloud SQL. If you are generating some kind of unstructured or semi-structured data like JSON files and all, in that case, you can store it in other table like in data store or in Bigtable. Okay, so these are the data ingestion services which are available in Google Cloud. If you are new to Google Cloud, please try to remember all these services because going forward, we are going to discuss about all these services. Okay, so please try to remember. Also, it will be helpful for you if you may not use all these things once you start working on a GCP project. You may not use all these things, but if you're going for certification, there you'll get questions from all the topics of GCP. Okay, so better try to remember all these services. Now coming to the storage. So for the storage, we know like there are different kinds of storage, that different kinds of data. We have different variety of data. So we have structured data, we have semi-structured data, we have unstructured data. Okay, so like other cloud platforms, Azure or AWS, here also we have different services in Google Cloud. Okay, for structured data, for unstructured data, for the semi-structured data. Okay, for example, structured data, we all know what is structured data. If your structured data is having a row and columnar format, so it's known as structured data. Unstructured data, for the transactional structured data, you can go for Cloud SQL or you can go for the Cloud Spanner. So there are some differences between Cloud SQL and Cloud Spanner. Based on that differences, you have to decide when you should go for Cloud SQL and when you should go for Cloud Spanner. Also, it will be asked you in the exam as well. They will give you some multiple choice question, and from that question you will have to identify that term or that key, based on which you will decide whether I should go for Cloud SQL or whether I should go for Cloud Spanner. But if you are doing some kind of transactional processing on structured data, you have to choose either of these two options. Either you can go for SQL or Spanner. Okay, for analytical processing, for analytical data, we are going for BigQuery. So BigQuery, if you have any idea about Hive, so BigQuery is almost similar to Hive, but the architecture of the BigQuery, how internally BigQuery store data, how internally BigQuery optimizes your data, so those things are different. don't worry, we'll discuss about that whenever we'll come to the BigQuery services. Okay. So, but for now, just understand, for analytical data, we are using BigQuery, and the BigQuery is almost similar to Hive. So you can store any kind of data, whether it's structured, semi-structured data also you can store in BigQuery. And BigQuery is not only for storing, you can do the processing of the data. Also, you can create machine learning model on using the BigQuery as well. Okay, so BigQuery is a very, very popular service in Google Cloud. Okay, so the competitor of the BigQuery are Redshift. We have in case of AWS, we have Databricks or Azure Synapse in case of Azure. Also, we have Snowflake. Okay, so these are the competitor of the BigQuery in the market. Okay, because they also provide same data warehousing solution. Now coming to the semi-structured data. So semi-structured data, you all know, like if it is the JSON file or kind of XML file. So those are semi-structured file or semi-structured data. So that can be two types of semi-structured data, not two types. So based on the types, if it is a fully indexed, okay, in that case, you will have to go for the cloud store, cloud data store, or cloud fire store. If it is again, don't confuse, like data store and fire store both are two different services. Again, there are some small differences between the data store and fire store. Okay, and if it is a row key indexed, in that case, you'll have to go for the big table. Big table is similar to what we have HBase in our on-premises system. So big table is similar to that. Okay, and the data store is similar to what we have the document databases like MongoDB and all. So data store and file store are similar to that. Okay, and then if you have unstructured data, if your data is completely like audio data, video data, so completely unstructured data, so in that case, you can go for cloud storage. Any kind of unstructured data, unstructured does not mean, you also in the cloud storage, you can store CSV file, PSV file, Parquet file, Avro file, everything you can store in the cloud storage. And cloud storage among with all these database services, or among all these storage services, cloud storage is the cheapest one. Okay, so that's why mainly for the so in the project you will try to use cloud storage as much as possible wherever you can, because it's the cheapest service of Google Cloud Storage of Google Cloud. Okay, and then for the processing of the data, we have many services. Okay, but we are mainly going to focus on the data proc, data flow, and data prep. Okay, so data proc is similar to completely Hadoop. Okay, Hadoop cluster. For example, I think someone told like you are migrating from Hadoop to Google Cloud. Okay, so in Hadoop you might be using some kind of distribution, either Cloudera or Hortonworks. So there you might have created some clusters, some master node, some worker node. So all those configuration, if you want to just lift and shift from your on-premises system to Google Cloud, in that case you can go for data prop. Okay, without thinking, without second thought, you can just go for data prop. Everything whatever your cluster configuration is, you can just create a replica of that in the data prop. Okay, and whatever you are using in your on-premises cluster, whether it's Hadoop, Hive or Yarn or Scoop, everything you can do in the data prop. Okay, also it supports PySpark, in Spark and Hadoop, both, everything you can create in data prop. And you can create a tunable cluster. As I told, you can create a custom cluster. You can customize your cluster based on your requirement, based on your existing on-premises system. Also, you can create data engineering system, data science, machine learning model, everything you can build on data prop. Whatever you can do on the data Hadoop, everything, all those things you can do in the cloud data prop. Okay. Now coming to the data flow. So data flow is so if you want to build a data processing pipeline, so there you can use data flow. And data flow, you don't need to do any kind of customization. Okay, so it's a kind of no operation services and it is fully managed. Okay, this fully managed term I'm going to use many times in this course. So fully managed means so it will be completely managed by the Google Cloud. You don't have to do anything. And in case of data flow, you can do both batch and streaming data processing. In data flow, you don't need to use Spark. You cannot use Spark. So there is something called Apache Beam. Okay. So whenever you are creating any pipeline, you have to write your code in Apache Beam in case of data flow, because data flow is built on top of Apache Beam. Okay. So also, if you don't want to code, there are some default template. There are many template which are available in case of data flow. So template means already predefined templates are available. If you will select one template, for example, you want to transfer your data from the cloud storage bucket to BigQuery. Okay. So you'll or pops up to BigQuery. Okay. So if you select that template, let's say you want to do the batch processing. So it will be divided whether you want to do batch processing or the streaming processing. Okay. So if you want to transfer your data, let's say batch data from the GCS bucket, from the Google Cloud Storage bucket to BigQuery, so you can select that template. Once you select that template, so that you will have to mention what are the source system, where you're in the storage system, in which file, in which folder your data is present, and similarly in the destination which you have chosen as BigQuery. So for BigQuery, you will also have to select the data set, project ID, and the table name. Also, there are apart from that, also there are some other dependency also which you need to select. So whenever you are doing a data transfer from the cloud storage system to BigQuery using data flow, and you can also schedule that as well based on your requirement. You can do a custom schedule, or daily you can run it, weekly run it. You can do that. Apart from that, there is one more services which is known as data prep. Okay, so data prep is actually not Google service. It's a it is actually the data prep is designed by the Trifecta. Okay, so that's a third party vendor. Okay, there are many third party services which Google is using, and Google has created one layer on top of that, and they are using that. Okay, they have just renamed that services. For example, Apache Airflow. Okay, Apache Airflow is not a Google service. Okay, but it's a third party service like Apache. It's a Apache service. It is designed and developed by the Apache. In Google Cloud, we have something called Cloud Composer. Okay, which is similar to Apache Airflow. Similar means on the background, on the behind, it actually using the Apache Airflow. Similarly, here in case of cloud data prep, so it's actually designed by the data it is designed by the Trifecta. Okay, so it's kind of you can say ETL tool, you can say. So using data prep, so it is it's a completely no code or low code platform. So what I mean by no code, low code means you don't have to code anything. You don't have to write any code using Python or Scala or SQL. It's completely UI driven. Okay, so just like Excel, the interface will looks like an Excel. You can filter your data. You can select any column if you want to remove any null values, or if you want to see the statistics of the complete column, what how many categorical values are there. If you want to make any changes on that particular column, or more than one column, everything you can do in the data prep. Okay, you can read the data from BigQuery or from cloud storage, and also you can store the data in all those platforms. Okay, so it's completely UI driven. It's completely a no code platform. You don't have to write any code. Everything you can do, all the data processing, all the data transformation, you can do on the UI. Okay, and again, it is fully managed by the Google Cloud. You don't have to create any size cluster, you don't have to mention like this should be the size of my hardware, or this should be size of my VM machine, or this should be size of my cluster. You don't have to mention anything like that. You can just create a data prep API enable, and you can create a data prep instance, and then you can start using it. Okay, so this was, apart from that, there are other services also like data fusion. Also, we are going to cover data fusion. Data fusion is completely similar to the data, not completely, it's almost similar to the data factory. Okay, so it's again another low code or no code service, and it's a ETL, for ETL tool we are using, for ETL kind of work we are using data fusion. Okay, apart from that also, like we have many services in order to visualize our data. So we have Google Cloud Studio, okay, where you can visualize your data. Also we have data lab. So data lab is similar to Jupyter notebook, where you can create Jupyter notebook instance, and you can go to the notebook, you can write some code to visualize your data. So okay, that is all about the data lab. Also, we have some machine learning pre-built API, some vision API, some speech API in Google Cloud, which are already built by the Google Cloud, and you can just use it. Okay. So all these visualization services which are already there in the GCP. Any doubts till now? There is any doubt? Hello.
No doubts, sir.
No doubts, Swagat.
Okay. So this was an overview of all these services which are available in Google Cloud, but we are going to discuss about all these services in detail, and individually we are going to focus on all these services. Okay. Apart from that, so let's discuss about some of the data engineering concept. As I told, we'll uh, spend 2 to 3 classes to discuss about some of the data engineering concept. Some concept, if you are already working in the data domain or data engineering, this concept might be, you might be knowing already. Okay, some concept might be new for you, but so this course has been designed for everyone and who is a completely new and beginner in the data field, in the no experience in the data engineering or any data scientist or data analyst. So they can also have some idea about the data engineering, what are the data engineering terms we use. So for that, so this course has been designed. Okay, so coming to the data processing part, we mainly have 2 kinds of processing. Okay, so one is our batch processing, another one is streaming processing of the data. So in case of batch processing, so usually what we do, so it's I can say the batch processing is a one-way door, or it's a one-way processing. So in batch processing, we usually process high volume of the data, large volume of the data. For example, if you have a job which is running weekly or monthly basis, and it's collecting and gathering all the data throughout that week or throughout that month, and then it is processing. So those kind of batch jobs will be handling large volume of the data, and this batch processing has been going on from the legacy system till now. Also we are doing with the batch processing, we are doing the batch processing as well. In case of batch processing, you all know the size of the data, how much volume of the data you are going to process, and that size is finite. Okay. So once the batch processing is completed, so you can send the response of the job either through mail or some any kind of log table, or any table if you have created, you can store your response of your batch processing job. So for example, for batch processing, we have let's say for billing system, for the payment system, for payroll. So all these are batch processing. Okay. Coming to the streaming processing of the data. So in case of streaming processing of the data, so either we do the processing real-time streaming processing or the near real-time streaming processing. So what will happen in case of streaming processing? We'll separate. You will divide our data into in form of windows or in form of micro batches. So there are different kinds of windowing concept. So there is split window, and then there are other types of windowing like overlapping windows concept as well. Okay, so there are different kinds of windowing concept, how you can divide your batches. Okay, and once you will divide your streaming data in form of batches, so we'll process each of that micro batches individually. Okay, and here in case of streaming data, we don't know the size of the data. Okay, and the streaming data will be coming continuously. Okay, and once the data will come, it will based on our window size, the data processing will happen in the system. Okay, so for example, the streaming processing, let's when we are processing the stock market data, or when you are processing the e-commerce transaction or social media data, so these are the examples of streaming processing of the data. Okay, now coming to the OLAP and OTP, OLTP processing and OLAP processing. Okay, so OLAP is online analytical processing. Okay, and OLTP is online transactional processing. Okay, so let's see what is OLAP and what is OLTP. What are the key differences between these two? Okay, so mainly the OLTP system is a simple transactional system, and it has been designed for handling the transactional data. Okay. Yeah, so the OLTP system it has been designed to handle the high volume of the transactional data. Okay, and the OLTP system is actually it's faster to queries, because in case of OLTP system, we can create indexes. Okay, so that you can there are different kinds of indexes mechanism, like cluster, non-cluster. uh, how the index you can design, there are different kinds of index index design mechanisms are there. But based on the indexes, you can query your data, you can do update, you can delete in a faster manner compared to OLAP in case of OLTP, because the systems are highly integrated. Okay, so highly integrated means so for example, you are let's say you are doing some kind of insertion or update. So highly integration means if you are ingesting the data from different systems, let's say you are ingesting the data from Oracle SQL, from SQL Server, from two more on RDBMS system, you are ingesting the data, and then you are putting the data into some data warehouse. Okay, to a destination system, to a particular destination system. So it is highly integrated, because whenever you are doing that ingestion, in case of OLTP, so you can do some joins, and you can like based on the keys and all, so you can do the join and you can do the ingestion faster. Okay, and OLTP is designed to modify the databases, as I told, because you are using key and primary key concept, unique key concept, and indexing. So it is easier to modify, like update, insert, and delete the databases in case of OLTP processing. Okay, whereas in case of OLAP, so where OLAP is for online analytical processing. So OLAP is actually designed to aggregate all the data. Okay, to whenever we are creating the data warehouse by ingesting the data from various sources. So that is the OLAP system. So OLAP system, we are just gathering all the historical data. Mostly we are not changing that data, we are not doing insert and update on the data. Okay, so it mainly built to aggregate all the, or we are not going to delete those data. So it is mainly built to aggregate all the historical data. And OLAP is not like it's not flexible to modify your databases. So modify your databases means to update, insert, and delete, those kind of operation we usually avoid in our databases. Okay, in case of OLAP processing. So it's mainly designed to do the query of the databases. Okay, to do the query processing. So that is why the OLAP is designed. Okay. Other than that, also like there are other differences as well. Like in OLTP system, if you see uh, the response time, because in case of OLTP, if you compare the response time, in OLTP we are using the all those indexing and the key concept. So the response time will be smaller compared to the OLAP. Okay. And application wise, if you see the some warehouse order entry and some let's say any kind of financial transaction, so there we use OLTP processing. OLAP processing, like if you are ingesting some kind of healthcare data or manufacturing data, so there we are using the OLAP processing. Okay. Then we need to understand what's the difference between the NoSQL and the SQL. Okay, so SQL is structured query language. We have different kinds of SQL databases. Okay, in the system. So like MySQL is there, then Oracle, then IBM DB2. So there are many different SQL databases are there. In case of NoSQL, what will happen? NoSQL. So in case of SQL, we mainly store the data in GBs or TBs data we stored in case of NoSQL. Whereas in case of in case of SQL, we store the data around the volume. The data volume will be around in some of GBs or in terms of TBs. Whereas in case of NoSQL, the data volume will be around TBs and petabyte level. Okay. And in case of SQL, so it is designed to handle low velocity of the data transfer. Whereas in case of NoSQL, you can do the processing very faster. Okay. And the common difference is like the structured SQL. The SQL is kind of structured data, and the NoSQL it can handle both semi-structured and the unstructured data. Okay, so the SCL compliances which is there in case of SQL, but we don't have that in case of NoSQL. So SCL is atomicity, consistency, isolation, and durability. Okay, so atomicity means in a table, if you are doing some kind of transaction, so it will either fail or succeed. So that's atomicity. Then we have the consistency. So consistency is your logic should be correct. Okay, so that's the consistency. Then we have something called isolation. So isolation, like if like multiple people are doing some kind of transaction, so that so we in order to avoid that confusion, or in order to avoid that collision between that multiple transaction, we have that isolation concept in case of SQL. Also, we have that durability, which is per D. Okay. But in case of NoSQL, we don't have those concepts. So in NoSQL, basically, we make the data available. Okay. And our data can be changed very fast. Okay. In case of NoSQL, so we don't want the consistency, but we want the eventual consistency. So there is a difference between the consistency and eventual consistency. So eventual consistency means at the end, your data should be consistent. Okay. But in case of NoSQL, throughout the transaction, sorry, in case of SQL, throughout the transaction, you maintain the consistency of the data. And also the SQL tables are normalized. Okay. So what I mean by normalized means, let's say there is one table, single table you have, which is having sales data, which is having marketing data, which is having customer data, which is having order data. Okay. So normally we prefer to create that type of table whenever we create a data warehousing solution, or whenever we create a NoSQL data, whenever we create a NoSQL table, because in NoSQL we store our data in a different manner. like in a row format, in columnar format. We have different concept of storing the data in case of NoSQL, but whereas in case of SQL, we prefer our table to be normalized. So for example, which I told, let's say you have a one table which is having SQL data, which is which is having sales data, which is having marketing data. Also, that table is having customer and order data. So when you normalize that table, so what we'll do, you will create a different table for each of this section of the data. Okay. For marketing data, you will create one table. Then for sales data, you will create another table. Customer data, you will create separate table. Order data, you will create a separate table. And whenever a transaction takes place, so all these tables, you will create a relationship across all these tables. Okay. There will be some primary keys, foreign keys. Based on that, you can create some relationship across this table, and whenever a transaction takes place in a OLTP system, all these tables will be updated, because since all the tables are integrated with each other based on the keys, so all the table, once a transaction takes place, all the table will get updated. But in case of NoSQL, we don't do that kind of update and delete. We don't prefer. So we store all the data in a denormalized manner. Okay. And the SQL system, which I told, like the Oracle system or the IBM DB2 system, so they are all like, tomorrow, if the data volume grows, if you want to scale your system, you'll have to add some additional hardware and all. In case of NoSQL, so that is known as vertically scalable. Okay, if you are adding some external cluster or external hardware in order to match up with your data volume, so that's known as vertically scalable. But whereas in case of NoSQL, you can go for horizontally scalable. So there are many optimization technique which you can follow, like creating partitioning, creating bucket. In case of NoSQL, in order to deal with to store the data in an optimized way in case of NoSQL. Okay. So that's these are the main differences. So when you're storing large volume of the data and the data does not have a proper structure, at that time you can go for NoSQL. Okay. And any, like, if the data volume is growing rapidly, so that case also you can go for NoSQL. Okay. Then let's understand what is so any doubts till now?
No doubts. You can continue.
Okay. Okay. So so let's discuss about what is the data warehouse. So in case of data warehouse, what we do, so data warehouse usually will be the final layer of your data pipeline. Okay. So where you will be storing the raw data, where you will be storing the structure and the process data in the data warehouse. Okay. And whatever the data you are going to store in the data warehouse, other teams or other the downstream application, they can consume your data. Okay. So the data will be ready to use format, or it will be ready to consume. Okay. And that data, whatever the data you are storing in the data warehouse, it will have some structure to it. Okay. And the main characteristics of the data warehouse are, so it will be subject oriented. So what I mean by subject oriented means, so whenever you are creating a data warehouse, it should be focusing, or it should be emphasis on the model which you are going to build, or the data analysis, or the decision making process which you are going to do by consuming the data in the data warehouse. Okay, so that is what subject oriented means. So your data warehouse should be focusing on some particular subject, whether you are going to store the sales data or marketing or distribution data. So it should be focusing on a particular subject. And then your data warehouse, so these are the characteristics of the data warehouse. So it should be integrated. So the integrated means, so whenever you are creating the data warehouse, so you are sourcing the data from various systems, whether it's a mainframe system or from relational files or from IoT devices or from flat files. You are sourcing the data from multiple system, you can see, and then you are storing the data in your data warehouse. Okay, so data warehouse, it could be either BigQuery or Snowflake or any other data warehouse system you are using. Okay, and once you store your data in the data warehouse, in the downstream application you can use, so which will be consuming the data from your data warehouse, and data which you are storing in the data warehouse, it will be time variant. So time variant means you can store the data for different time. You can store the historical data, you can store the current data as well. So that is what time variant means, and the data should be non-volatile. So the non-volatile means any new data which enters your data warehouse. Okay, so that does not mean that your old data will get deleted. Okay, so your both old data and the new data will be there in your data warehouse. Okay, and mainly we create the data warehouse for only read-only purposes, and it gets refreshed periodically, the data warehouse. Okay, usually we avoid the delete, update and insert operation into the data warehouse. Okay, so that's the characteristics of the data warehouse. And next let's discuss about the data lake. So data lake, if you can see this slide, so here you can see that this is a three-tier structure of the data warehouse. Okay, so there is a bottom layer. So there is a bottom layer. Okay, you can see. Then there is a middle layer. Then there is a top layer. Okay, so the data lake usually will be your first layer. Okay, so mostly we prefer to store our data in the cloud storage because it's a cheapest service which is available in the Google Cloud. So mainly we prefer to store our data or all the raw data or the unstructured data in the data lake layer, and data lake we usually build on top of cloud storage in the Google Cloud. Okay, and this data, it's not ready to consume. Okay, you have to process that data, then only it will be ready to consume. Okay, but the structure of the data warehouse, sorry, the data lake is flexible. Okay, and also it's a low cost storage, as I told. After the data lake, you will have a staging layer. Okay, the staging layer you can create in BigQuery, or you can use same data, same cloud storage as well for the staging layer. Also, like you can create a data warehousing layer. So after the staging layer, you will process your data, then you can create a data warehousing layer. Okay, and after the data warehousing layer, in some project also, you will see the data mart layer as well. So data mart layer, it's a subset of data warehouse, you can say. It is specifically designed to focus on a particular service line or particular business line. So let's say in a project there are finance application and the sales application, you want to divide that data. Okay, so whatever the data you have stored in the data warehouse, again you want to segregate your data. For finance application, you want to store the data in the data in finance data mart. For sales data, you want to store in the sales data mart. So you can create another layer also, so that you can call data mart layer. Okay, and then we have something called data lakehouse, which I was talking about. So data lakehouse is a pretty new concept. So data lakehouse, it's a completely pretty new concept now in the market. And data lakehouse, it has the advantages of both data lake as well as data warehouse. Okay, so the data lake, if you see, there are certain disadvantages of the data lake as well. Mainly for the poor performance, and you don't have the data governance, and data, like you don't have a fixed structure to your data, so the schema you cannot create. And the SC transaction support is also not there in case of data lake. Similarly, there are certain disadvantages of data warehousing as well. For example, data flexibility, which is there in the data lake, that is not there in case of data warehouse. Also, in case of data warehouse, if you compare the cost, so the cost will be higher than the data lake. Okay, so to adjust both of this data lake and data warehouse, we have something called data lake house. Okay, and data lake house, so it's a combined approach of both data lake and data warehouse. So it has certain advantages, like it will reduce the data redundancy, or of course the cost will be reduced. Okay, also you can give a structure to your data. So once you give a structure, or once you can create a schema to your data, you can do all those asset transaction on top of your data. Okay, so once that is done, then you can do the data versioning, you can do the data governance. So data versioning and the data security also you can do on that. Okay, so that is about the data lake house. And as I told, Databricks is working mainly on this data lake house now, and they are promoting the data lake house because they are using the delta lake concept, okay, to build this data lake house. And also many company has started using this data lake house as well. Okay, so now coming to the ELT and ETL. Okay, so ELT is extract, load, and then transform. But ETL, you'll use, like, you'll transform, you'll extract your data, then you will transform your data, and then you will load your data. So that is what ETL means. Okay, so in case of ETL, so mainly when we'll go for ETL and when we'll go for ELT. So ELT now industry, most of the projects are using the ELT framework. So ELT, yeah, ELT framework. ETL you can use when you are having small volume or medium volume of the data, because once you extract your data, before loading the data to your target system, as you can see, before loading the data to your target system, you can use, you can do the transformation of the data. Okay, and if your data volume grows, in that case, the loading will be slower. So in that case, we can just load all our data. We can go for the ELT approach. So where you will just extract, you load all your data to your data warehouse or to the staging layer, you can say, and then from the staging layer you can transform your data. But here, before loading the data, you will have to do the transformation of the data. Okay, so the ETL was old approach, but right now we are using the ELT approach mostly. And in case of ETL, you'll have to do the compute intents, because before loading, you'll have to transform all your data. You have to clean your data. You have to do all kind of filter and data processing, and then you can load your data. But in case of ELT, so it's less complex, because you can do the transformations. Like once you store your data in the data warehouse, then you can use some SQL query and you can run the to do the transformation. Okay, so that's the difference between ETL and ELT framework. Okay, so that any doubts till now?
No doubt.
Okay. Okay, guys. If you don't have any doubt, then I'll stop the class here. From the next class, we'll discuss about the data modeling. What are the types of data modeling methods are there? How you can create a data model? All those concepts we'll discuss from the next class. So I think it will take 2 more class to just complete this data engineering concept, and then we'll get into the GCP and we'll start discussing about the GCP services. If you have any doubts, you can ask, or else we'll wrap up the class.
Hello.
Yeah,
Yes, you can go ahead.
Actually, I have one doubt. I don't know about the Python. I'm not familiar with the Python. Even though will this course help people?
see, in this course, we will not start discussing about the Python from the very beginning, like this dictionary, all those beginner level concept we will not discuss. But whatever the code we are going to use in this course, I'll explain you everything. So that even if you don't know Python, also you'll be able to understand. Okay, at least if you have some coding background, you'll be able to understand whatever the program we are going to write or whatever the code we will use. So it will be mostly on PySpark, Python, and SQL. So you'll be able to understand. Don't worry about that. But if you want to learn Python, you can like you can watch some videos in like, or you can like there are many materials and videos which are available. You can go through that if you want to have some knowledge on the Python. I think in the last class, I think somebody asked me. So you can go through. There is one website called W3 School. Okay, from there you can start learning about Python. And whoever does not know about SQL also are completely new to the IT. So they can also go through that W3 School website, and you can gain some beginner level knowledge in Python and SQL. Okay.
What about the practicals, Swagat? How are you covering your practicals?
Yeah, of course. We are covering practical. We'll do all the hands-on in the GCP services. So like right now also we are doing for our previous batch. Everything we'll do in the console itself. So if you need to create a free tier account in the GCP, and there we are going to cover all the concept, like all the practical. I think you didn't attend the demo class. In the demo class, I showed you like we did some practical using 4 services of the GCP, like I think data proc, BigQuery, storage, and the cloud composer. We did some hands-on. Whether you were there in the first class, in the demo class, or you were not there?
No, I was not there.
Okay. Yeah, we are going to cover the practical search. It's not only theory. Right now we are discussing theory because I think some student might be new to the data engineering domain. Some student might want to switch from other non-IT domain to IT. So for them, like I'm not going in detail. I'm just like discussing some of the concept on a high level. Yeah, so this is the GCP account. You can see the console, and we are doing lots of hands-on. So for the previous batch we are doing, so their batch is almost complete. Yeah, similarly also you can see like there are some free service, sorry, the free trial account you can create, and then you can practice in the console. You will get $300 credit for 90 days, and that is more than enough. So to practice. Right, you can see like I think almost only 10 days left for my just free trial account. I'll have to create another account. So you can I'll show you how to create. Nowadays actually they have made their policy a bit more strict. So you might be facing sometimes issues while creating the free tier account. So some specific credit card or debit card you'll have to use. You cannot use the credit card of all the banks. So I'll tell you like how to create a free trial account.
Okay. So other than this GCP services, are you going to show us anything, something like a Red Hat for pipeline creations, Visual Studio for project creation?
Red Hat?
Yeah.
No, Red Hat. Why you need Red Hat?
For deployments and all. Project deployment from the local.
Okay, deployment, like you have the cloud build tool. So DBT is there. which you can
Mhm.
like. There are no, we are only going to focus on the GCP services. We are not going to use any external services like what your Red Hat and all. So Red Hat, I don't have knowledge on Red Hat, but you can use the this one, the cloud build tool is there. Also Kubernetes is there, which you can use. So if you want to create a pipeline and you want to deploy your data pipeline, so there you can use this DBT. Red Hat, yeah, I'm not, I don't have knowledge on the Red Hat and all.
Okay.
Can you please show us a final project? So what are the projects you're planning to cover? So entire integrity. So if you're using all the tools, right? So
See, there is no final, there is no one project. It's not like, see how the course is designed. Like whenever we'll discuss about the, let's say, cloud storage. So whatever the hands-on we can do using only cloud storage, we'll do that. Then again, we'll discuss about, let's say, BigQuery. So whatever the hands-on and the practical we can do using BigQuery and cloud storage, again, we will do that. Apart from that, the hands-on which you saw in the demo class, okay, so that was using Cloud Composer, BigQuery, Dataproc, and then cloud storage. So once we have discussed all these 4 services, then only we'll go and do that hands-on. So there is no final project like this many projects. It's a complete hands-on course, okay. 70% of things we are going to do on the hands-on, we are going to practice. So we'll discuss theory and then we'll do the hands-on. There is no such final project or no such things like, yeah,
okay.
it's completely hands-on course. We are not going to discuss the theory much. We will focus equally both on theory and both on the hands-on. But yeah, as I told, once all the services are discussed, then only the hands-on we can do.
Okay.
So let's say, for example, if we complete this GCS, we'll do the hands-on on the GCS. Whatever the hands-on we can do using GCS, we'll do that. Similarly, whenever we'll discuss the BigQuery, and we have covered both GCS and BigQuery, combining those 2 services, whatever the hands-on we can do, we'll do that. Similarly, like other services, once we'll cover one services, we'll try to use those services and we'll do some hands-on. So that is how this course is designed.
Okay.
Yeah. See, the cloud knowledge you need to gain so that you can utilize it. It's not like the big data course, so where you will be learning and you will all the theory, and then you will do some 2 to 3 project. So that is not how you'll do here, because it's a cloud services. Your focus should be on how you can utilize those services, okay, in your project. So that should be your focus. Your focus should not be like, I learned all the services, then I'll do the hands-on, I'll do some 2 to 3 project and my job is done. No, that should not be your focus. You should learn about all the services, and then you should know how and where you can utilize the services in your project or in the future project where you are going to work. Also, we support, like we can give you some sample resume if you are moving to data engineering domain, if you don't have prior experience, so you can follow that and you can put some 2 to 3 years of experience in the in GCP as well.
Okay.
Yeah. Anything else?
I hope everyone is fine.
Oh, thank you. Thanks, guys. Thanks for
Tomorrow,
joining.
same time, Swagat.
No, tomorrow will not have any class tomorrow, Sunday. So we'll have next class on Monday. Our usual time, like 9 p.m.
Yeah. Just a second.